This is SpaceTime Series 23, Episode 85. Coming up on SpaceTime, new theories suggest the asteroid Psyche could actually be the core of an unformed planet, a new discovery about the Higgs Boson, and satellite navigation systems have become essential to our way of life. But just how do they work? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study of the main-belt asteroid Psyche suggests it could be the remnant of a planet that never formed. The findings, reported in the journal Icarus, are based on new computer modelling of the 200-kilometre-wide asteroid's major impact structures. Scientists undertook three-dimensional simulations of the likely impact to have generated the structures seen on Psyche, finding that the asteroid is most likely metallic and porous in composition, something like a flying cosmic rubble pile. Previous radar observations indicate Psyche has a dense, largely metallic composition, with a surface around 90% metallic and 10% silicate rock. Scientists think the metals which make up most of Psyche are probably iron and nickel. Based on the available data, it now appears Psyche is likely to be the remnant of a planetary core that was disrupted during its accretion stage. The new study's lead author, Winnie Caldwell from the Los Alamos National Laboratory, says knowing this will be crucial for NASA's upcoming Psyche mission, slated to launch in 2022. The mission will be the first to visit a metallic asteroid, and the more the scientific community know about Psyche prior to launch, the more likely the mission will have the appropriate tools for examining this primordial world and collecting data. Caldwell says that modelling impact structures on Psyche contributes to science's understanding of metallic bodies and how cratering processes on large metallic objects differ from those on rocky and icy worlds. The computer simulations found the best fit was an oblique impact angle where the upcoming object would have struck the asteroid surface, deforming Psyche in a very specific and predictable manner, given the likely materials involved. See, metals deform differently to other common asteroid materials such as silicates. In the early stages of crater formation, the target material behaves more like a fluid. In the modification stage, however, the strength of the target material plays a key role in how material that isn't ejected settles into the crater. The findings corroborate the estimates on Psyche's composition based on observational measuring techniques. Of particular interest is the material thought to provide the best match, Monel. Monel's an alloy based on ore from the Sudbury crater impact structure in Canada. The ore is thought to have originated from the impactor that formed the crater, meaning the ore itself is likely to have an extraterrestrial origin. This is SpaceTime. Still to come, new discoveries about the Higgs Boson. And satellite navigation systems have become essential to our way of life, especially travel. But how do they actually work? All that and more coming up on SpaceTime. Physicists at CERN, the European Centre for Nuclear Research, have witnessed the Higgs Boson decaying into a pair of muons. It's the first time scientists have detected these characteristics by the so-called God particle. The Higgs is called the God particle because it gives mass to other particles through an all-pervasive Higgs field. Muons are heavier versions of electrons, one of the elementary particles that constitute the matter content of the universe. But while electrons are classified as first-generation particles, muons belong to a second generation. The process of the Higgs decaying into muons is a rare phenomenon, with only about one Higgs in every 5,000 decaying into muons. The new results have pivotal importance for fundamental physics because they indicate for the first time that the Higgs can interact with second-generation elementary particles. Physicists at CERN have been studying the Higgs ever since its discovery in 2012 in order to probe the properties of this very special particle. The Higgs boson was produced out of proton collisions at the Large Hadron Collider, the world's largest atom smasher. As the protons collided, they disintegrated, referred to as decay in physics, almost instantaneously into two other particles. One of the main methods for studying the Higgs properties is by analysing how it decays into various fundamental particles and the rate of that disintegration. Scientists with the CMS, one of the major detectors at the Large Hadron Collider, achieved evidence of this decay with 3 sigma certainty, which means the chance of seeing the Higgs decay into a muon pair from statistical fluctuation is less than 1 in 700. Meanwhile, scientists with another detector at the Large Hadron Collider, known as the ATLAS collaboration, recorded a 2 sigma result. Now, 5 sigma remains the gold standard in particle physics. But the 2 results combined still means there's a better than 3 sigma chance, and hence reasonably strong evidence, that the Higgs really does decay into 2 muons. The Higgs interaction with second-generation particles like muons fits in with current predictions under the Standard Model, the foundation stone of science's understanding of the universe. Further testing during the next run of the Large Hadron Collider will gather additional data, hopefully cementing the results. By measuring the rate at which the Higgs decays into different particles, physicists can infer the strength of their interaction with the Higgs field. The higher the rate of decay into a given particle, the stronger its interaction with the field. So far, the ATLAS and CMS experiments have observed the Higgs decay into different types of bosons, such as W and Z bosons, as well as heavier fermions such as tau leptons. The Higgs interaction with the heaviest known quarks, the top and bottom quarks, was measured back in 2018. Now, by comparison, muons are much lighter, and their interaction with the Higgs field is weaker. Interactions between the Higgs and muons had therefore not previously been seen. What makes these studies even more challenging is that for every predicted Higgs decaying into 2 muons, there are literally thousands of muon pairs being produced through other processes that mimic the expected experimental signature. The results scientists are currently working on use the full data set collected from the second run of the Large Hadron Collider. The characteristic signature of the Higgs decay into muons was a small excess of events that cluster around the muon pair mass of 125 gigaelectron volts, which just happens to also be the mass of the Higgs boson. But isolating the Higgs to muon pair interactions hasn't been easy. To do so, both ATLAS and CMS experiments measure the energy momentum and angles of muon candidates from the Higgs boson decay. The sensitivity of the analysis was improved through methods such as sophisticated background modelling strategies, as well as other advanced techniques such as machine learning algorithms. The CMS collaboration combined 4 separate analyses, each optimised to characterise physics events with possible signals of a specific Higgs boson production mode. ATLAS divided their events into 20 categories that targeted specific Higgs production modes. With more data to be recorded during the Large Hadron Collider's next run, the teams at ATLAS and CMS are expected to reach their 5 sigma sensitivity levels needed to establish the discovery of the Higgs decay into 2 muons and constrain possible theories of physics beyond the Standard Model that would affect this Higgs decay mode. This is SpaceTime. Still to come, we look at how satellite navigation systems work, and South Korea's first military telecommunications satellite launched into orbit. All that and more still to come on SpaceTime. And time now for a word from our sponsor, the Great Courses Plus. There are so many benefits to lifelong learning. That's why I love the Great Courses Plus. You can expand your curious mind, build upon your skills, improve your memory and self-confidence. The list goes on. Created for the lifelong learner in all of us, this streaming service provides access to thousands of fascinating fact-based lectures across almost any topic imaginable. And the courses are taught by world-leading professors and experts. In fact, the list of presenters reads like a who's who, with some of the best minds from some of the best universities on the planet. And there's a huge variety of topics to explore, such as the aging brain, great trials in world history. You can even learn how to cook or play chess. And with the Great Courses Plus app, it's easy to watch or listen anytime, anywhere. And it's great for any age, even high school or college students. Now, this week I've been checking out a course called The Remarkable Science of Ancient Astronomy. If you love history and astronomy, this could well be the course for you. Some of the topics covered obviously include Stonehenge, the ancient pyramids, and Anastasia astronomy. There's meteorite worship and the start of the Iron Age all the way up to the end of ancient astronomy around 1500, and how all this history fits in with today's understanding of astrophysics. Each lecture runs for around 30 minutes, so it's easy to digest. Now, I really like this one, and I think you will too. And if you haven't done so yet, now's the perfect time to sign up for the Great Courses Plus, because as a SpaceTime listener, you get to check out any course or lecture for free. That's free access to their entire library. Literally thousands of topics to choose from. So why not give it a try? After all, what have you got to lose? Don't wait any longer. Sign up today using our special URL. That's thegreatcoursesplus.com/space. thegreatcoursesplus.com/space. That way you'll be helping to support our show. And you'll find those URL details in the show notes and on our website. That's thegreatcoursesplus.com/space. And now, it's back to our show.
This is SpaceTime with Stuart Gary.
Satellite navigation systems provide global geolocation and time information to receivers, which these days are small enough to be included in your cell phone. Better yet, you can receive these signals knowing exactly where you are in latitude, longitude, altitude and time, anywhere on Earth where there's an unobstructed line of sight to 4 or more navigation satellites. As well as several smaller local satellite navigation systems operated by countries like India, the world currently has 4 major satellite navigation networks. There's America's Global Positioning Satellite System GPS, the European Galileo Satellite Navigation System, Russia's GLONASS, and the Chinese BNU. The American, Russian and Chinese systems were all designed primarily for military use, with some belated civilian and commercial applications made available later. And that's where the European Galileo system's so different. It was always intended to be a civilian and commercial use system. Galileo went live in 2016 with 26 live satellites. Ultimately, the constellation will include 30 satellites in 23 222-kilometre high orbits, providing accuracy below a metre. But how does it all really work? This report from ESA TV.
A Global Navigation Satellite System, or GNSS, is formed by a constellation of satellites and a ground system spread over the world. The user on the ground, like our smartphones or the navigator in our cars, receives the signal that is transmitted constantly by every satellite on the Earth, and from some specific parameters of this signal is able to determine the position on the ground. Although the process of computing the position is in practice very complex, you can imagine measuring the distance of yourself and all satellites with a rope. And from all these measurements, your navigator is able to determine your position on ground. And this is possible wherever you are, in Europe or in China, or on a mountain, on the sea, in a sunny day or in a stormy or in a cloudy day. The only thing that you need is to see a portion of the sky. Of course, you want the navigation to be precise enough. You don't want your navigator to bring you off-road because it told you were in a completely different place. For this reason, the ground system plays a really critical role. It measures the quality of the signals that is transmitted by the satellites by means of antennas which are spread all over the world. And then corrections are computed and sent periodically to the satellites. Now, of course, the GNSS in general is much more than that. Galileo, for example, the European Satellite System, for example, provides services for precise timing with an outstanding precision, or supports search and rescue systems for localizing people in trouble and allow them to ask for help. Also, it supports European governments by providing services which have a very high precision for sensitive applications. Satellite navigation is nowadays very important for our daily life, and you are using it more often than you can think. Have you ever sent your location through WhatsApp? Or have you ever shared the place you are through Facebook? And have you ever wondered how Pokemon Go could know where you are and where the Pokemon are? Also, the most obvious application there is road navigation, which allows you to visit your friends or a delivery truck driver to find your place. So we are so used to navigation with smartphones that for us, navigating with a paper map or reading the road signs to understand our position or finding the route is really a distant memory. And can you imagine what it's like to navigate in the sea where your only reference is the stars and a paper map? Now, all ships in the world today, they use GNSS to navigate. But GNSS is very important, especially in emergency. If you are, for example, a skier and you are hit by an avalanche, or if you have lost your path through the mountains, or if your boat is broken, then navigation is the only way you have to let people know where you are so that you can be rescued. Losing the satellite navigation services for just one day would then create an enormous damage to our lives. Of course, we cannot repair satellites. We can repair ground equipment. For this reason, all the components of the ground are constantly monitored and maintained. Every day we experiment the benefits of satellite navigation, but this is just the beginning. Now, if navigation is very precise and reliable, why should you look at your navigator and steer the wheels of your cars if you could just let it do it for you, just relying on navigation information? The delivery of packages could happen through cars or drones without the need of a driver, directly to your home. Robots could autonomously patrol our cities for improving our safety. Now, this seems like far future, right? Actually, this is something we are really close to do. But in order to do that, we need to continue improving satellite navigation. And this is mainly for two reasons. The first one is that we would really literally put our lives in the hands of an electronic system. And this is a tremendous challenge because failure will not be an option anymore. Secondly, there are men out there which have learned how to steal our systems, how to break into our smartphones, and they could, for example, steal our packages or even really bring us off-road, just penetrating into our navigators. So these are the highest priorities today for future innovation. And I have a question for you. What about the Moon and Mars then? Well, astronauts will need to navigate over the Moon and over Mars, and they would need, sooner or later, a satellite navigation system for them. And this is one of the most exciting and great challenges of the next future.
And that report from ECTV featured Nicola De Quattro, the head of engineering and innovation at Vitraset in Belgium. This is SpaceTime. Still to come, South Korea's first military telecommunications satellite launched into orbit. And later in the science report, a new species of sauropod dinosaur discovered in China. All that and much more still to come on SpaceTime. SpaceX has successfully launched South Korea's first military telecommunications satellite into geostationary orbit. The Anasis 2 was flown aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Air Force Station in Florida.
LD countdown net, go for launch.
There we go. The final call to SpaceX launch director is given to go for launch.
Stage 1 tanks pressing for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
M1D propulsion is nominal.
Everything looking good. That's the call out. Says M1D engines are throttling down, getting ready to reduce vehicle acceleration in preparation for the period of maximum dynamic pressure. We're in the bottom of the throttle bucket, as they call it. Now the Merlin engines coming back up to full power as we get ready to go supersonic.
Vehicle is supersonic.
Supersonic, we're coming through the period of maximum dynamic pressure.
Vehicle has reached maximum aerodynamic pressure.
Guidance engineer confirms we're through the period of greatest pressure on the vehicle. Continuing downrange, trajectory looks good. Propulsion looks good. Avionics looks good.
MVAC chill has started.
That announcement from Stage 2 propulsion. We are now beginning to chill in the turbo pump on the upper stage engine to get ready for its ignition. We head east out of Space Launch Complex 40 into the first of two orbits planned for today. This orbit is the parking orbit, a low Earth orbit trajectory that will take us over the equator and will eventually relight the upper stage engine to transfer us into the desired geostationary transfer orbit. Now, main engine cutoff, or MECO, coming up in several seconds, followed by pneumatic separation. The first stage pushes away from the second stage, and then ignition of the second stage engine.
Stage separation confirmed.
MECO on time. Stage sep looks good. And the call-out MVAC-D engine is at full power. The large titanium grid fins now slowly opening. That begins about a 2-minute period as we slowly rotate the first stage around to get it ready to come back through the atmosphere and land on the drone ship in the Atlantic off the east coast of Florida. Second stage engine glowing red, the MVAC-D. Trajectory is nominal, we've heard from the guidance engineer. We're coming up on fairing deploy.
Fairing separation confirmed.
And we've heard the call out from the avionics engineer. Fairing separation is confirmed. Power on the upper stage engine is good. Bermuda is now getting the telemetry from the Falcon 9.
Following main engine cutoff and stage separation, the Falcon 9's first stage landed successfully on the drone ship, just read the instructions, which had been pre-positioned downrange in the North Atlantic Ocean.
The next milestones coming up include that first stage's entry burn, followed by the second stage engine cutoff known as SECO-1, the first stage landing burn, and then that hopeful landing. The first stage has reached apogee. It's beginning to head down there. We're only going to be firing 3 of our Merlin engines during this entry burn in order to slow the vehicle down before it gets to the thicker parts of Earth's atmosphere. It'll slow the vehicle by about 25%. When we perform stage separation, that first stage was traveling about 2.5 kilometers per second, so we have a lot of velocity to reduce. Entry burn beginning, it's going to last about 24 seconds.
Stage 1, entry burn startup.
The center engine fires first, the 2 side engines fire shortly after that.
Stage 1, entry burn shutdown.
All right, 1 burn down, 1 to go. That's the landing burn, along with the next milestone, the second stage engine cutoff, or SECO-1. That'll be at T plus 8 minutes, 7 seconds. During SECO-1, we shut down the second stage MVAC engine.
Also signal first stage Cape Canaveral expected.
In about 25 seconds after SECO-1, Falcon 9 will touch down, hopefully, on our drone ship. Just read the instructions. Currently, it's in the Atlantic, about 350 nautical miles off the coast of Florida.
Start of terminal guidance.
And in terms of velocity of that first stage, drag alone is slowing the first stage down another 80%. That landing burn will take us back to get that last 20%, touch us down safely.
SECO.
Stage 1, landing burn startup.
We have confirmation of both landing burn and SECO-1. We're waiting confirmation of a good orbital insertion for that Anasis 2 satellite. And the landing
Stage 1.
So, landing laser deploying now.
Nominal park orbit insertion.
And there it is. That is our 57th successful landing of Falcon 9 on our drone ship. Just read the instructions. We also had confirmation of nominal orbit insertion. We're all pretty excited over here at SpaceX for being able to use this first stage for a 3rd time coming up. But going back to our primary mission on the second stage, it's going to coast for about 18 minutes until we cross the equator, where we perform the second of 2 burns of the upper stage to help change the orbit.
The same course stage had previously launched the Crew Dragon 2 second demonstration flight, carrying NASA astronauts Bob Behnken and Doug Hurley to the International Space Station. The 6,000-kilogram Anasis 2 satellite was built by Airbus Defence and Space on a Eurostar 3000 platform as part of an offset package into the purchase of 40 F-35 Joint Strike Fighters. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has shown that COVID-19 infections are linked to heart damage, perhaps as a result of direct viral infection. One study of 100 German patients who had recently recovered from COVID-19 found that 78 had abnormal heart readings on cardiac magnetic resonance imaging, and that 60 had signs of heart inflammation independent of any pre-existing conditions. A second study found that people who died of COVID-19 were found to have the virus within the heart muscle. You can read the findings in full in the Journal of the American Medical Association. Meanwhile, a new study warns that despite earlier claims, kids under 5 may be important drivers of the COVID-19 virus spreading. The findings, which were also reported in the Journal of the American Medical Association, found that young children with COVID-19 had more of the virus's genetic material in their noses and throats than older children and adults. Mind you, the study only looked at viral genetic material known as RNA, rather than the infectious virus itself. But researchers say other studies have already shown that more virus can be grown in the lab when samples from kids with high RNA levels are used. The authors say the behaviour of young kids and their close contact in schools and childcare settings raise concerns for the virus spreading as public health restrictions are eased. Scientists have discovered how sleep helps improve your memory. The neurons in your brain that help you learn and remember things have a cartilage-like sheath around them known as a perineuronal net. Now, a report in the journal eNeuro claims catching some sleep could loosen the sheath enough to help make strong memories stronger and weak memories weaker. Scientists investigating how these nets vary during sleep found that an enzyme that alters these nets comes into play cyclically during sleep. They say this would suggest that a good sleep lets your brain loosen up the nets, which in turn allows for changes in your memories. Paleontologists in China have found fossilized fragments of a new species of sauropod dinosaur. The findings, published in the journal Scientific Reports, shows that Irisosaurus yemenensis was about 5 meters long, with a typical sauropod-like neck and tail, but it walked on just 2 legs, using its forelimbs more as hands. The fossils, dating back some 195 million years to the early Jurassic, were found in Yunnan province. A report in the journal Nature has described traditional Chinese medicine as being fraught with pseudoscience. It found the most obvious reason that traditional Chinese medicine hasn't delivered many cures is because most of its so-called treatments don't work, as they have no scientifically logical mechanism of action. Instead, it uses a bunch of made-up ideas, like vital energy or qi moving through magical channels called meridians, which supposedly have branches connected to bodily organs and functions, which can then be guided by acupuncture points. None of it has any scientific validity. Add to that a hodgepodge of potions based on mixtures of herbs and body parts, many from rare and endangered species, or extracted from live animals through extreme cruelty, which also don't work other than through a placebo effect, and you end up with what today is traditional Chinese medicine. Even the name's phony. The doctrines of traditional ancient Chinese medicine were actually invented in the 1950s in the wake of Chairman Mao's Communist Revolution. Mao didn't actually believe in ancient or traditional Chinese medicine, so he preferred modern Western medicine instead. After all, it worked. But he ordered the use of traditional Chinese medicine for the masses as it was more affordable. A clear example of the Soviet Union's communist doctrine of everyone being equal, but some being a little bit more equal than others. Now, health authorities in Beijing have unveiled proposed new regulations which will make it a criminal offence to defame or slander traditional Chinese medicine. Under the new laws, breaching what would become known as Article 54 would be punishable by public security departments for disrupting public order. Tim Mendham from Australian Skeptic says that's a vaguely defined crime often used by Chinese law enforcement to police online speech.
The Chinese are making a big push for TCM, traditional Chinese medicine, to be taken up around the world. They probably see it as much as a branding thing, branding for China as a leader in treating and looking after people, etc., and just promoting Chinese culture, etc., even though traditional Chinese medicine in many cases is not part of a long-standing culture, but that's beside the point. But, they're trying to push it. So the suggestion is that as China becomes, if it can be, more authoritarian, down to, individual sort of thought police, they're suggesting that there's a proposed article in a new regulation that says that anyone who, quote, defames and slanders TCM, so that's the medical practice itself, not the individuals who do it, but just the fact of traditional Chinese medicine. If you defame or slander it, you're subject to punishment, quote, public security departments. You might face criminal charges for picking quarrels or causing trouble and disrupting public order. Now, this is...
neither of us will be allowed to go to Hong Kong now.
Oh, no. Oh, damn. It's a very strange thing. This is apparently a vaguely defined crime that's some Chinese authorities are saying. It's a vaguely defined crime that's often used by Chinese law enforcers to police online speech, okay? And it's an all-encompassing thing. It's very vague. It's very open to criticism, which it has been criticised within China as well as outside. Some of the Chinese authorities are coming back and saying, oh, sorry, we didn't actually mean it that way, but actually, what we're talking about is defamation and slander are different to criticism and false arguments. But it's it's such a vague sort of regulation that it could really be open to any interpretation. And people in China who are concerned about, law and order and not stepping over the law and order issues could be very worried enough so that they don't criticise TCM, let alone defame it and slander it.
Well, in any totalitarian regime, there is that need to control and regulate the population, isn't there? You need to keep them under the hammer. But if people start thinking for themselves, they may realise there are problems with your form of government. So
well, that's right. And that's something which is
under control. And that's a huge deal in China.
And whatever particular thing you might point towards, whether it's medicine or online activity or who knows what, it can be used as a tool to get in and further control people. And certainly it just sets up a mindset by which people are frightened to actually speak out about anything. And unfortunately, that's the way China's increasingly going.
At a very fast rate too.
Don't forget, the Chinese party has been in control since the late 40s.
Yeah, but we've seen for a while there, things were getting better. So from a Western point of view, and I know this is not part of your remit here with Australian skeptics. So.
Well, it's partially because it does involve things like traditional Chinese medicine, which has an enormous amount of questions about not just its effectiveness, but also its practices, such as using wild animals and that sort of thing, which leads on to the potential for things that are happening now, like pandemics, right? And previous epidemics and pandemics have been caused by the same sort of problem of dealing with wild animals where you do not know where they come from or what they've been exposed to, and that leaves you open to these sort of things. So this sort of rule supporting TCM, and we've had problems with the TCM proponents in Australia. One of the groups, a research group in Sydney, Western Sydney University, won our Ben Spoon Award because of its promotion of traditional Chinese medicine and the associated products, including sort of promoting the extinction of rare animals. So the way that TCM is being promoted, whether within China or internationally, is of great concern to the skeptics, because it does revolve around some major pseudoscience.
And some huge ethical concerns as well, especially with endangered species.
That's exactly right, and that's what our sort of criticism covered. But they didn't even know, this research group in Australia, that some of the stuff they were linking to was promoting killing endangered animals, but they're still heavily promoting TCM. And they got a lot of sponsorship from China at the same time.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.